Okay, part 2. Sorry for that because of the 10-minute time limit of my video. So we ended up with this problem. How many liters of ozone can be destroyed at a temperature of 200 Kelvin and a pressure of 7 kilopascal if there are 55 grams of chlorine gas that react to it according to this balanced chemical equation? So we figured out the temperature is 200 Kelvin, pressure, the 7 kilopascal has to be converted to atmosphere. So that means you cancel out kilopascal and the pascal here to get an atmosphere. Same thing because you're given the mass of 55.0 grams of Cl2, but you're asked for ozone. That means this is where your stoichiometry calculation will be. Your mass of Cl2 has to be converted to mole of O3 because you need mole in the ideal gas law. This is not STP. That means you need to use the ideal gas law. So our 55 gram Cl2, we divide it by the molar mass of Cl2 so that we can cancel out the gram Cl2, and then we also cancel out mole Cl2 and get mole O3 through the mole ratio in the balanced chemical equation, which is 1:2. Then we get 1.55 mole O3. So we got three variables already. We have temperature, P, and then this will be our N value. This is our N because it's already in mole. Next is we need to put the R also. So R is 0.0821. Remember, you need to memorize this. Liter atmosphere per mole Kelvin. So that's our R. Next is we need now to get our volume from your ideal gas law. So we know that ideal gas law is PV is equal to nRT. So to get V, that's going to be over P. So V is equal to nRT over P. Now we can substitute. Our N is 1.55 mole. Our R is 0. Sorry, let me erase that, the point. Okay, 0.0821 liter atmosphere per mole Kelvin times the temperature of 200 Kelvin over the P of 0.07 atmosphere. So inputting all that once in the calculator, we will get a certain answer. But let us analyze first the cancellation of the unit. Mole will get cancelled out, Kelvin will get cancelled out, atmosphere will get cancelled out, and so you're left with a unit of liter. So inputting all of that in the calculator, we will get an answer of 36.36 liters. If the problem will ask you to express it in m cube, for example, liters to m cube, that means you have 1,000 liters in 1 m cube. So you can just divide that by 1,000 if you want to make it in cubic meter. If you want to make it in milliliters, that means you need to multiply that by 1,000 because in 1 liter there are 1,000 millimeters. So this is now the answer for our problem about the ozone. So you're asked for the volume of ozone in liters using the variables that you're given, but take note that the stoichiometry is in the part of mass wherein your Cl2 has to be converted to O2. So some points to take note, when you're doing gas stoichiometry calculations. Gas stoichiometry involves basic stoichiometry calculations. It can be mole to mole, mass to mass, or mass to mass. And usually, calculations involving gas molecules connect with the mole quantities as you've seen in the roadmap. Analyze the variables that you are given so that you will know what gas laws and conversion factors to use, which you have two options, either the ideal gas law or the 1 mole is to 22.4 liters. If the conditions are at STP, that means 1 mole of anything will have a volume of 22.4 liters. And then if it's ideal gas law, remember the law, the equation, PV is equal to nRT, in which the R has a value of 0.0821 liter atmosphere per mole Kelvin. And take note, the temperature has to be in Kelvin unit, pressure has to be in atmosphere, volume has to be in liters, and N for the number of moles of the substance you're looking for. Refer to the conversion formulas and factors discussed in the previous video and in this video. Mistakes to avoid: if you don't convert the proper units, and you start with the wrong substance and the wrong values with the wrong calculations, and you don't follow the stoichiometry roadmap. So that's it for now. Let me just end with our stoichiometry roadmap. This will be the thing that you need to remember so that you will be guided with your calculations. Okay, so that's it for now. Watch out for the next challenge problem that you need to solve in your class. Bye.